Hello friend and welcome to my next practical tutorial in which I will show you how to expose web endpoints using Spring Boot 3 and Kotlin router DSL, aka functional style. So basically the Kotlin router DSL comes in three variants. The first one, which we can use when working with a standard MVC Spring project. The second one, which we can use when working with a reactive stack framework, Spring Web Flux. And the last one, as the name suggests, the one which we will use when working with Kotlin coroutines. And although in this article we will make use of the coroutine based REST API implemented in reactive REST API with Spring, Kotlin and coroutines, the knowledge you're gonna gain today is universal and will work regardless of the implementation. So, with that being said, let's start the project setup, and as the first step, let's navigate to the GitHub repository, for which link you will find in the description for this video or in the article I was mentioning as well. And let's firstly clone the repository to our local machine. Following, please import this to your favorite IDE, for example to IntelliJ just like I did, and wait a second for Gradle to fetch necessary libraries. When we navigate to the controller package, we will see that the project consists of three controllers, the one responsible for company management, search controller, and the one responsible for users. And for the purpose of this tutorial, we will focus on the API responsible for users management. So when we go right here and open up the user controller, we will see that we have a couple endpoints responsible for users management, like create user, find all users, find user by ID, the endpoint to delete users, and the last one to update user by ID. So the first thing we can do right here will be removing all the annotations we can see. So let's remove these two. Let's get rid of post mapping, request mapping, and all of the annotations we have right here in this file. Let me get rid of this one. Put mapping, path variable, and request body as well. Let me close this dialog window. Nextly, let's hit Ctrl+Alt+L and format the file. And lastly, let's annotate this class with a component annotation. Component annotation. In simple words, with this annotation, we instruct Spring Boot to create automatically a bin of the user controller for us. Lastly, let's create a new package and we'll rename the user controller and move to it. So click new package and let's call it handler. Right here, I will rename the user controller to user handler. And lastly, we can simply click in this project window and move the class into the handler. Let's click OK, and IntelliJ will take care about imports, rearrangement, etc. With all of that being prepared, we can create a new config class and take care about configuring our routing. So let's click on the main package here, right mouse button, new package, and I will call it config. Inside this package, I would like to add a new class, so right mouse button, new Kotlin class, and I will call it config as well. And we have to annotate this class with configuration, annotation. Wonderful. As the next step, we will implement a new function called router. So first of all, it will be responsible for definition of a new bin, so we have to annotate this with a bin annotation. Nextly, I will call it simply router, and as an argument, it will take a user handler. So as you can see, this is the reason why we have annotated the user handler with component annotation. Of course, you could do it as well manually inside this class, so the choice is up to you. Following, let's start implementing routing. So we will make use of the coRouter. As I mentioned in the beginning, when working with coroutines, we will be using coRouter. Nevertheless, if you are working with standard approach or Spring Webflux, then you will be using simply a router. Anyway, let me get back to coRouter. Great. Nextly, I will write accept and specify the media type which we would like to match with particular routes. So media type dot application underscore JSON. Nextly, let's click nest. So basically the nest function allows us to structure routing in a neat and readable manner. So let me start by typing /API/users and again nest. Right here I will define all the HTTP methods we had in our controller. So let's start with post. And this will go to the root. So we don't have any more nesting here. And let's specify the function which we would like to trigger when the HTTP post method will hit our API. So user handler and create user. At this point the code will not compile, nevertheless I will explain why in a moment. At this point let's add the remaining functions. Get. The pattern also will be an empty string, and user handler we will reference to find users function. Nextly, let's add the route to find user by ID. So this will be get, and this time the pattern will match the path variable ID, and user handler will be find user by ID. Nextly, delete. Similarly, / and ID path variable to delete user by ID, and let's search for delete user by ID. And lastly, the put endpoint, so put HTTP method / again path variable and user handler update user. Wonderful. So basically, as we can see, this approach is a great way to structure our routes in the application. For example, let's add some versioning. So API nest. Right here I could go with v1 and nest some endpoints under this, and similarly I could do with v2 nest, and here provide additional handlers. So instead of separate controller classes, we can manage everything in one place. Of course, this is not a golden bullet for every problem in our standard approach, but for some of you, it may better suit your need. Anyway, let me get rid of these lines. And as I mentioned, the code will not compile, and the reason is pretty straightforward. We can open up, for example, the post function, and we can see that it requires us to provide the pattern, but also a function which will take the server request as an argument and return the server response. So basically, when we get back to user handler, we will see that all of our functions take different arguments like user request, string values, or long values for path variables. We have to rewrite all functions to take the server request as an argument and return server response instead. So let's start everything with create user. Instead of user request, we will take server request of type server request. Let me select everything and enclose that with curly braces. Wonderful. As we can see, we have to read somehow the payload and provide the user request mapped to model to our service. So the first thing we are gonna learn is reading the payloads. So let's start with val user request equals server request await body, and let's select the one where we can specify the desired type. So I would like this to be user request K-class. Wonderful. At this point we do not return anything, so I will have to change this right here, server response, and we'll have to take care about it right here. So for example, let's introduce a new variable, val user response. And as the last thing, let's implement return server response. The server response has a couple of predefined functions allowing us to return the appropriate status code. Nevertheless, if you would like to specify some custom one, then you can simply go with status. Anyway, I would like this function to return 200 OK, so I simply will invoke the OK function. And lastly, as the user response is a standard object, not a flow, then I will have to invoke body value and await. Body value and await, and right here I can specify the user response. Now when we get back to the config class, we'll see that this line is working as expected. So let's do the same for find users. Again, instead of the name, request server request, enter, and we have to return server response, enter. Nextly, we will try to read the optional query parameter and we'll call it name, so val name equals request parameters, and we can see that we can choose between a couple of functions: query params, which returns all parameters for this request, the query param which returns the optional. Nevertheless, in our case, when working with Kotlin, the best choice will be query param or null, and right here we have to specify the name of the param, and this was name. When we have the name, then we can leave everything as is, or on the other hand, we can go with val users. Let's put it here, and instead of that, we can use it in the same line. Nevertheless, right here we have to specify the name, Ctrl+Alt-L, and the code is a bit cleaner in my humble opinion. Instead of returning the flow of user responses, let's introduce a new variable, val user responses equals, and lastly, again, we have to return the server response. So return server response, okay, and this time we will use the body and await, which, as we can see, takes a flow as an argument. User responses. Ctrl+Alt-L, everything seems to be working as expected, and again in config we can see that this line is okay now. Let's get back to the handler and let's take care of find user by ID. This time we will learn how to read a path variable. So again, request server request. Right here, server response. Let me select everything, hit shift and specify the curly braces. Remove this one. Ctrl+Alt+L. Let's reformat the code. So as we can see, we have the identifier missing. So let's try to read it from the request. Val ID and right here request path variable. Again, we can choose between fetching all variables as a map or fetching a particular path variable. I will go with the path variable and specify the identifier. Nevertheless, we cannot parameterize this function, so we have to manually take care about conversion, because to find the user by ID, we have to have a long value. The easiest way, and let's say a naive approach, will be to go simply with too long. Nextly, let's introduce a user response variable, val user response equals, and lastly, let's return the server response. So return server response, okay, and right here body value and await and provide the user response. As we can see, manually we are creating only the OK server response, and we simply throw the response status exception so that the user will be informed that the particular user is not found. Anyway, there is a second way which we can do that. So instead of throwing the response right here, we can go with optional user response and then manually create the appropriate server response. So I can show you that now right here. The user response will be optional user response. So what I can do will be simply return user response, let response, and right now we can simply copy this and put it inside this block. Of course, we have to provide the default response if the user is not found. Server response not found, and build and await. Of course, you can provide your custom response body. Nevertheless, I will go with the empty body and 404 not found. So as we can see, with this approach, we have a bit more of a flexibility. We can either throw the exception or manually compose the server response. The choice is, of course, up to you. Similarly, let's go to config class and verify whether the app should compile now. This is good. And we have two more handlers to convert. So let's get back to user handler and let's take care of delete user by ID. So this time, again, instead of taking the ID, we'll need to take the request of server request and respond with server response. Ctrl+Alt+L. Again, I will have to read the identifier val ID equals request path variable name ID, and let's convert that to long. Nextly, we simply trigger the delete user by ID function. This one returns the unit, so we don't have anything to read right here. So lastly, I would like to simply return the no content 204 without anybody. So return server response, no content, and build and await. So this way the API consumer will receive 204 no content without anybody. Lastly, let's switch to the update user function and make the necessary adjustments. So let me remove these two. Request, server request. Wonderful. Again, right here, server response instead of the user request. Let's close that. Wonderful. Firstly, let's read the identifier and nextly the payload body. So val ID equals request path variable ID to long value and val user request equals request await body, and let's specify the K class. So this will be user request class. Hit enter, Ctrl+Alt+L, and we can introduce a new variable called response val, or maybe user response. This will be more readable. And lastly, again, I will return the 200 OK with the payload. So return server response OK body value and await. And let's specify the user response, Ctrl+Alt+L. Now when we go to the config class, we can see that the code compiles and we can finally test our application. Nevertheless, this will be a part of your homework, so as your homework, firstly, please test whether the routing works fine after we converted our Spring controller to the functional style. And additionally, if you would like to, then you can refactor the company controller and search controller classes in a similar manner, just like we did in this video. This way you can learn more and remember a bit more about what we've learned today. In the description for this video, as a bonus, you can find the Postman collection for all the endpoints in this project. And additionally, if you switch to the router DSL branch in my GitHub repository, then you will find a solution for this homework. And basically that's all for this video, in which we have learned how to expose web endpoints using Spring Boot 3 and Kotlin router DSL, aka the functional style. I really hope that you enjoyed this content, and if this is the case, then please let me know in the comment section. Thank you for watching and see you in the next videos.